The visual of a tropical beach is so universally coded into our psyche as paradise that we have stopped seeing it altogether, perceiving only a static painting of leisure. But let's deconstruct that painting from the ground up, starting with the very stage it sits upon, the sand. That soft, white or golden powder is not merely pulverized rock. It is a historical archive and a brutal battlefield in most tropical regions, especially the coral atolls and volcanic islands of the Pacific and Indian Oceans. The primary component of beach sand is calcium carbonate, the skeletal remains of countless marine organisms. Every grain you sift through your fingers is a ghost, a fragment of coral, a shot of shell from a foraminifera, or the spine of a sea urchin, all ground down by ocean waves over millennia. This biological origin is the first secret. A tropical beach is, quite literally, built from death and persistence. The famous whiteness is a sign of purity and age, the leaching out of all organic pigments by sun and sea, leaving behind a mineral starkness. However, the color spectrum tells a deeper story. Papakalia Beach in Hawaii is green, saturated with the mineral olivine from volcanic activity. Pink sands, like those in the Bahamas or Bermuda, get their blush from microscopic fragments of crushed foraminifera with red-pink shells. Black sands, like those in Tahiti or the Canary Islands, are born from rapid volcanic quenching, where lava meets the sea and shatters into fine, obsidian-like granules. This sand is not inert. It hosts a hidden metropolis known as the interstitial ecosystem, the thin film of water between grains. In this microscopic world, an entire food web thrives. Bacteria, diatoms, nematodes, and tiny crustaceans like copepods, all engaged in a constant cycle of predation and decomposition. This hidden biome is the unsung foundation for shorebird life. It processes nutrients and cleanses the water that filters through. But this foundation is under direct assault. The global demand for construction sand, second only to water as the most extracted resource, has spawned a brutal illegal sand mining trade. In places like Jamaica and Indonesia, entire beaches are literally stolen overnight by sand mafias, loaded onto barges and shipped to make concrete for urban expansion, often in wealthy, land-reclaiming nations like Singapore. This isn't just erosion. It is the surgical removal of an ecosystem's base, leaving behind a scarred, lifeless substrate. The sand's temperature is another critical overlooked factor for sea turtles, which have navigated to these beaches for over 100 million years. The sand's thermal properties determine the sex of their offspring. Cooler sand produces males, warmer sand produces females. With rising global temperatures and decreased shading from vegetation loss, beaches are now producing clutches of eggs that are over 90% female. A demographic time bomb that threatens the long-term survival of species like the critically endangered Kemp's Riley or hawksbill turtle. The beach, therefore, is not a passive strip of land. It is a dynamic, living record, a nursery, a filter, and a commodity in a multi-billion-dollar black market. Its stability is an illusion maintained by a delicate balance of biological production and physical forces. When we admire its curve, we are admiring the momentary ceasefire in a war between land and sea, a ceasefire that our actions are rapidly breaking. The mist that hovers above the water at dawn, our titular image, is the first visible sign of the colossal energy exchange happening here, the warm sea releasing vapor into the cooler morning air. But that mist is also a veil hiding the intense and vulnerable life, history, and conflict compacted into every single grain beneath our feet. This leads us directly to the next layer, the interface where that mist forms, the water itself, which holds secrets far darker and more consequential than the sand. Transitioning from the solid to the liquid, the turquoise water lapping the shore is the engine of the mirage and the source of its greatest peril. The iconic clear, blue-green hue is a function of pure physics, the selective scattering of sunlight. In deep, nutrient-poor water, molecules scatter the shorter, blue wavelengths of light most efficiently, giving the open ocean its deep blue. Near the shore, the presence of dissolved organic matter from plants like seagrass, suspended photosynthetic microorganisms, and the reflective white seafloor scatters green and yellow light, creating the brilliant turquoise palette. This color is not just aesthetics, it is a health indicator. A clear turquoise signifies a relative lack of planktonic life, typical of coral reef environments which thrive in oligotrophic, low-nutrient conditions. But this stunning clarity is a paradox of poverty. The water is so clear because it is so nutrient deficient. And the entire reef system has evolved to recycle nutrients with breathtaking efficiency in a desert-like seascape. The mist hovering above it is the visible breath of this engine, the process of evaporation, where the sun's energy transforms liquid water into vapor, beginning the hydrological cycle that governs global weather. The temperature of this surface water is the single most important variable for life on Earth. Tropical seas act as the planet's solar panel, absorbing immense heat and redistributing it via ocean currents like the Great Conveyor Belt. The warm water here, particularly in regions like the Coral Triangle or the Caribbean, evaporates rapidly, fueling the formation of clouds and ultimately the meteorological systems that bring rain to continents thousands of miles away. This makes the tropical beach not a remote getaway, but the boiler room of global climate regulation. However, this engine is now overheating. Data from NASA and NOAA shows that sea surface temperatures have been breaking records consecutively, with 2023 and 2024 seeing the highest global averages ever recorded. For the coral reefs that are the architects of the beach and the bedrock of biodiversity, this is a death sentence. When water temperatures rise just 1 to 2 degrees Celsius above the seasonal average, the symbiotic relationship between coral polyps and their microscopic algae, zooxanthellae, breaks down. The stressed corals expel the algae, losing both their color and primary food source, leading to coral bleaching a stark, ghostly white skeleton. Prolonged bleaching leads to mortality. The Great Barrier Reef has suffered 5 mass bleaching events since 2016, with over 90% of corals surveyed showing some level of bleaching in recent events. But the tragedy is deeper than dead coral. The reef's structure, built over centuries, begins to erode without living tissue to maintain it. This erosion breaks down into sediment, which can smother surviving corals and alter the very composition of the beach sand, shifting its texture and ecology. Simultaneously, the overheated water supercharges weather systems. Warmer air holds more moisture, and warmer seas provide more energy for storms. This leads to more intense and unpredictable tropical cyclones and hurricanes, whose storm surges and powerful waves become catastrophic erosive forces, scouring away beaches, uprooting coastal vegetation, and reshaping coastlines overnight. Furthermore, the chemical composition of this water is changing. The ocean absorbs about 30% of anthropogenic carbon dioxide emissions, leading to ocean acidification. As CO2 dissolves, it forms carbonic acid, lowering the water's pH. A more acidic ocean makes it harder for corals, mollusks, and the very plankton that form the base of the marine food web to build their calcium carbonate shells and skeleton. This is a direct chemical assault on the foundational building blocks of the entire ecosystem. The mist then becomes a symbol of transience and fragility. It is the visible moment of the ocean giving up part of itself to the atmosphere, a transfer now accelerated by the heat we have added to the system. The serene, warm water is not just a pleasant swimming hole, it is a critical buffering life support system that is undergoing a fever, and its symptoms, bleached reefs, fiercer storms, and acidified chemistry are screaming for intervention. This overheating body of water directly impacts the third critical component of the scene, the line where the sand and water meet, the intertidal zone and its fringe of vegetation, which is the fragile glue holding this entire paradise together against the rising tide. At the precise margin, where land and sea engage in their daily dance of tides, exists the most biologically intense and physically demanding zone on the planet, the intertidal fringe, often guarded by a forgotten army of trees, the mangroves. This is the true fortress of the tropical coast. And its degradation is the silent crisis unraveling the postcard from the edges inward. When we picture a tropical beach, we often imagine it fringed by coconut palms, but the ecologically critical frontline vegetation is the mangrove forest. These are not mere trees. They are biological marvels and hydrological engineers. With their complex, stilt-like root systems, they are perfectly adapted to saline, anoxic, oxygen-poor soils. They filter up to 90% of sediment and nutrients running off from the land, protecting the clear, coral-friendly waters offshore. Their roots provide nursery habitats for countless juvenile fish, including 75% of all commercially caught tropical species, and for crustaceans like shrimp and crabs. A single mangrove forest can host a greater biomass of fish than the adjacent coral reef. Furthermore, they are colossal carbon sinks, sequestering up to 4 times more carbon per hectare than mature tropical rainforests, locking it away in their waterlogged soils for millennia. This blue carbon is one of the planet's most efficient climate mitigation tools, yet, according to the Global Mangrove Watch, we have lost over 35% of the world's mangroves since the 1980s, primarily for shrimp aquaculture, coastal development, and palm oil plantation. The loss is catastrophic. Without the mangrove buffer, the erosive energy of waves hits the beach directly, stripping sand away at an exponential rate. The nutrient runoff from agriculture, now unfiltered, floods into coastal waters, causing eutrophication, algal blooms that cloud the turquoise water, choke corals by blocking sunlight, and create dead zones devoid of oxygen. The mist that forms over the water nearby now carries not just pure sea vapor, but potentially the smell of decay from these algal die-offs. Beyond the mangroves, on the beach itself, lies another vital vegetative line, dune plants like sea grapes, beach morning glory, and grasses. These plants are the sand's anchor. Their complex root systems bind the sand particles together, creating a living net that resists wind and wave erosion. They capture blowing sand, allowing dunes to build upward and landward, forming a natural shock absorber against storm surges. When these are cleared for unobstructed hotel views or beach access, the sand becomes mobile and defenseless. A single storm can then erase a beach entirely, as seen in places like North Carolina's Outer Banks or the eroded coasts of Goa. The intertidal zone itself, the wet sand exposed and covered twice daily, is a powerhouse of productivity. It is here that a process called biogeochemical cycling goes into overdrive. Microbes in the sand engage in nitrification and denitrification, essentially converting pollutants into harmless nitrogen gas. Sand bubbler crabs and mollusks filter feed, cleaning the water. This zone is the kidney of the coast. However, pollution from plastics, sunscreens, and sewage is poisoning this kidney. Chemical sunscreens containing oxybenzene and octanoate washed off millions of swimmers are now proven to cause coral bleaching, DNA damage in marine life, and hormonal disruption in everything from sea urchins to fish. A 2015 study estimated that around 14,000 tons of sunscreen coral bleaching chemicals are deposited into oceans annually, with much of it concentrating in these popular tropical beach destinations. The beach is no longer just a natural system. It is a chemical soup. The mist rising from the water at a resort beach may now contain aerosols from these contaminants. The cohesive story of the vegetation and the intertidal zone is one of interconnected defense. The mangroves are the standing army, the dune plants are the home guard, and the microbial life in the sand is the medical corps. They work in unison to protect the integrity of the shore, purify the water, and support the food web. Their systematic removal for short-term economic gain is akin to dismantling a castle's walls on the eve of a siege. And the siege is coming not just from the sea, but from the very people who flock to admire its beauty. Which brings us to the fourth, and perhaps most profound layer, the human narrative, the economic engine. the cultural significance, and the paradoxical threat that tourism itself represents to the very scene it covets. The human gaze upon the tropical beach has transformed it from an ecosystem into an idea, a commodity, and a geopolitical asset, setting in motion a feedback loop of consumption that now threatens to consume the resource itself. The tourism industry built upon the paradise imagery is an economic colossus. In the Caribbean, tourism contributes over 15% directly to GDP and employs millions. In small island developing states, SIDS, like the Maldives or Seychelles, it can account for over 70% of economic activity. This dependency creates a powerful, often desperate incentive to package and sell the beach experience at any cost. The standard development model is brutally extractive. Clear mangroves and dunes, dredge sand to widen beaches, build concrete resorts with freshwater guzzling golf courses and swimming pools, import food and materials, and generate immense waste in an environment with limited processing capacity. The very infrastructure of tourism exacerbates every ecological threat we've discussed. Groundwater is over-extracted, leading to saltwater intrusion that kills remaining terrestrial plants and contaminates drinking supplies. The energy demand, often met by diesel generators, contributes to the very emissions that warm the planet and acidify the ocean. The waste, particularly plastic, ends up in the sea, entangling wildlife and breaking down into microplastics that now permeate the sand, the water, and the very mist. 2021 study found microplastics in sea breeze aerosols. But the cultural impact is equally transformative. For indigenous and local coastal communities, the beach is often not a place of leisure, but of livelihood, spirituality, and identity. It is a fishing ground, a burial site, a ceremonial space, and a communal area. The privatization of shorelines for exclusive resorts, a process sometimes called coastal grabbing, displaces these communities, severing their cultural and physical connection to the sea and leading to a loss of traditional ecological knowledge that was key to sustainable management. The tourist gaze also creates a demand for a curated, sterile version of nature. Pest species like certain birds, crabs, or insects are removed. Sand is mechanically raked clean of natural seaweed, wreck, which is a vital food source for birds and a fertilizer for dune plants. Lights from hotels disorient turtle hatchlings, leading them inland to their deaths instead of toward the moonlit sea. The beach becomes a stage set, an ecological ghost of its former self, maintained only for photo opportunities. Yet, within this bleak narrative lies the seed of the only viable solution: economic revaluation. The emerging fields of natural capital accounting and ecosystem service valuation are putting hard numbers on what nature provides for free. A healthy mangrove forest value in storm protection, fishery support, and carbon sequestration can dwarf the one-time profit from its clearance for a shrimp pond. Coral reefs are estimated to provide goods and services worth $375 billion annually globally through fisheries, tourism, and coastal protection. Insurance companies are now beginning to invest in reef and mangrove restoration as cost-effective climate adaptation, recognizing that a healthy reef can reduce up to 97% of a wave's energy before it hits the shore. This data-driven approach is a powerful tool. It shifts the beach from being seen as a passive backdrop to an active, valuable, and necessary piece of infrastructure. It argues not for its preservation out of sentiment, but for its investment out of stark economic and survival necessity. The mist hanging over the water, in this context, becomes a currency, a sign of a functioning hydrological and climatic system that has immense, quantifiable worth. The tourists who come to see it are not just visitors. They are beneficiaries of a life support system they are often unwittingly degrading. The challenge, therefore, is to transform the tourism model from extractive to regenerative, to make the human presence not a parasitic force but a symbiotic one. This leads us to the final integrative paragraph, A synthesis of all these layers and a clear, actionable path forward, because understanding a crisis is only half the battle. The other half is forging the tools to fix it. We have journeyed from the microscopic world, in a grain of sand, through the overheated, acidifying engine of the sea, along the defensive lines of mangroves and dunes, and into the complex human economy built on this fragile paradise. The tropical beach with soft mist is not a simple picture. It is a dense, throbbing nexus of geology, biology, chemistry, physics, climate, culture, and economics. Every element is interlocked. The death of coral from warm water weakens the sand production line. The loss of mangroves exposes the shore to erosion and kills fishery stocks. The raking of sand destroys dune plants, leading to erosion that requires expensive, often futile, artificial replenishment. The tourism that drives it all pumps carbon and pollution into the system, accelerating the cycle of destruction. This is the great feedback loop of coastal collapse. But this interconnectedness is also the key to salvation. The solutions must be equally systemic, moving beyond symbolic bans on plastic straws to fundamental redesign. First, protection must be data-driven and legally enforced. We need marine protected areas, MPAs that are truly no-take and highly monitored, allowing ecosystems to rebuild resilience. Technology like satellite monitoring and AI-driven pattern recognition can catch illegal fishing and sand mining in real time. Second, tourism must be radically reimagined. The future lies in low-impact, high-value ecotourism that educates visitors on the complexity we've outlined. Resorts must be built with closed-loop water systems, renewable energy, and mandatory green infrastructure. Tourism fees should directly fund local conservation corps and scientific monitoring. Third, restoration is not a feel-good hobby, but a critical infrastructure project. Coral gardening, assisted evolution of heat-resistant corals, and large-scale mangrove reforestation are engineering tasks on par with building seawalls, but far more effective and sustainable. Emerging techniques like using reef stars or 3D printed structures to provide substrate for coral growth show immense promise. Fourth, we must empower and integrate local and indigenous communities as the primary stewards. Their traditional knowledge, combined with modern science, is the most potent management tool we have. Community-managed marine areas have consistently outperformed top-down government efforts in restoring fish, stocks, and ecosystem health. Finally, on a global scale, the fight to reduce carbon emissions is the fight to save tropical coasts. Every fraction of a degree of warming averted means less coral bleaching, less intense storms, and slower sea level rise. The mist over the water is a daily reminder of the planet's breath, of the immense life-giving exchanges that happen here. It is the visible symbol of a system that can either be a climate regulator or a casualty. We have the data, we have the economic arguments, and we now have the moral imperative. The paradise is real, but it is a working paradise, a machine of survival whose gears are grinding. We can either be the wrench in those gears, or the oil that allows them to turn smoothly for millennia to come. Final call to action. If this deep dive has reshaped your understanding, if you now see the beach, not as a backdrop, but as a battlefield and a living lifeline, then your responsibility is clear. This knowledge must translate into action. First, engage right here. Smash that like button to amplify this data-driven message to the algorithm. It tells YouTube this is important content. Second, subscribe and hit the bell. We are not done. Next, we will deconstruct other paradises like alpine forests and rainforests with the same 5,000-word evidence-based rigor. You need to be here for that. Third, comment below. Tell me one fact from this script that shocked you the most, or ask the most pressing question this raised for you. This builds our community of the informed. Fourth, take this knowledge into the world. When you travel, Choose certified eco-resorts. Demand that your tour operators support local conservation. Vote for leaders who understand blue carbon and ocean acidification. Use mineral-based sunscreen. Support NGOs doing on-the-ground restoration work. Share this video with someone who loves the beach. They deserve to know the truth beneath their feet. We are at a tipping point. The mist over that tropical water is the breath of a planet, and it's holding that breath, waiting to see what we do next. Don't just be a viewer, be a participant. Subscribe, act, and let's protect the reality behind the postcard together.